Welcome to Hartman Math. Before we get to inverse trig functions, let's do a quick warm-up based on our trig function here. Pause here until you've worked through all 6. All right, number 1, period. We're talking about the graph. Sine would be 2 pi divided by b, so we would get pi. Amplitude, since a is -1, amplitude would be the absolute value of that, 1. Phase shift, c divided by b, positive pi over 6. The average value is the d, which is 1. This one's tricky, the zeros of the function. We might want to see if we work that out. So if we're talking about the zeros, go ahead and set it equal to 0. So if we subtract 1 from both sides and then divide by -1 on both sides, we've got the sine of our 2x minus pi over 3 is equal to 1. And that looks complicated, but let's say we were just talking about sine theta equals 1. Where is the sine of theta equal to 1? Straight up, pi over 2. So we'd essentially be thinking of 2x minus pi over 3 is equal to pi over 2. Now solve for x. So we can add pi over 3 to both sides. So we're talking about 3 pi over 6 plus 2 pi over 6. 5 pi over 6 divided by 2, you get 5 pi over 12. And that's one of them. It's not all of them. Remember, this is our interval. And our period is stated at pi. So not only at 5 pi over 12, but pi units past that also. So 5 pi over 12 and 17 pi over 12. And then secant of 5 pi over 4, well, cosine of 5 pi over 4 in quadrant 3 is negative root 2 over 2. If we flip that, we get negative 2 over root 2. Although you don't have to rationalize the number, you do always have to simplify, and that does become simplified negative root 2. This is lesson 4.7, inverse trig functions. If we were looking at the sine function, and we're talking about let's come up with the inverse of that sine function, the first thing we would recognize is the inverse is not going to be a function, because this doesn't pass the horizontal line test, which says it would have a function. So essentially what that means is we have to kind of cut this down and only look at a part that would pass. And it needs to cover all of the values from -1 to +1. So where we actually look at it is from here to here, from negative pi over 2 to positive pi over 2. That's the part that we look at. And then when we do the inverse, we can switch x's and y's, and we can graph that. So the definition of the inverse, if we're talking about y equals arc sine of x, that's the inverse of sine. Or we can also use a different notation, which we'll take a look at shortly. And that's true if sine of y is equal to x. The domain of the arc sine function is between -1 and 1. So you cannot take the arc sine of 5. If you try to do it on a calculator, it's going to give you some sort of an error message. The range, and this is really important, these are the answers that you're going to get, have to be between negative pi over 2 and positive pi over 2. We're going to use the unit circle to help us out, but we can't get an answer like 7 pi over 6. Because it doesn't fall within the range of the function. Example number 1, evaluate. So first of all, we're talking about the answer is an angle. So we're saying arc sine of 1/2, come up with the angle such that the sine of that angle is 1/2. But keep in mind that the answer has to be between negative pi over 2 and positive pi over 2. And unless it says otherwise, we're going to answer in radians. So if we're thinking in terms of unit circle, Where is the y-coordinate 1/2? That's long on the x, short on the y. So that's going to be pi over 6. And we can think of that in terms of the unit circle, but only looking at this part and only looking at these as positives here and negatives here, not as 3 pi over 2 and 11 pi over 6 and so on. So these are the ones we want to look at. Y-coordinate of 1/2, that happens right here, 30 degrees, but we're going to go in radians, pi over 6. Here's the other notation, sine inverse of -1, so same situation, arcsine, sine inverse, synonyms. So they mean the same thing, the inverse sine of -1. So again, we're looking for a y-coordinate of -1. It happens here, so the answer is negative pi over 2. Not acceptable would be 3 pi over 2. Well, the sine of 3 pi over 2 is -1. That's not an acceptable answer. If I was writing it on paper, I would put NIR, not in range. Answer has to be between negative pi over 2 and positive pi over 2. We can do similar things for cosine. So y equals arc cosine or inverse cosine. Same situation on the domain. A different situation, however, on the range. You would be thinking in quadrants 1 and 2. Couldn't be 1 and 4 because cosine's positive in both of those. We're looking 1 and 2, positive, negative. Tangent's going to be very similar to sine in that, in terms of its range, the output is almost identical. It just cannot be negative pi over 2 or positive pi over 2 because that's where we have the graph has asymptotes. But the domain is a little bit different in that we can take the inverse tangent of any number. It will never get an error message. You can always get an answer. So arc cosine, negative 3 pi over 2. Think unit circle. Where is the x-coordinate negative root 3 over 2? That would be long going left, short going up. I think we're talking about 5 pi over 6. We check our unit circle, quadrants 1 and 2 only, because these are the only acceptable range values, outputs, answers. Here's the x that we're looking for. It is 5 pi over 6. Inverse tangent of 1. Okay? So we're back to looking at quadrants 1 and 2. Remember, the tangent is the y-coordinate divided by the x-coordinate. That ratio needs to be 1, and that tells us that our coordinates need to be equal. So where does that happen? It happens at pi over 4, where our coordinates are root 2 over 2, comma root 2 over 2. Y divided by x would be 1, so it's going to be pi over 4. All right, now what about using calculator to approximate round to the nearest thousandth? So once again, we're looking for an angle. We want it to be in radians, so make sure your calculator is in radians. So for arctangent, we're going to press the inverse tangent button, which can be right above tangent, so you probably have to press second or shift, tangent, 1.9 equals, should get about 1.086. Same thing here. We can try that. Second cosine, as you see right above cosine, it says cosine -1, indicating inverse cosine. Second cosine, negative pi over 3 equals, it might give us an error message because I don't think we're allowed to do this. Negative pi over 3, well, pi is a little bit more than 3, 3.14159, so on. divided by 3, that's going to be like negative 1 point something. That's not in the domain of our function, which is why when you put it into the calculator, it's going to give you an error message. There is no such thing. That is not a real number, so that's undefined. The next thing we're going to look at is composing a trig function with an inverse trig function. The first thing we're going to look at is when they somewhat match. Okay? And our tendency is to think that they might just cancel each other out, as that's generally what inverses do. They cancel each other out. We might get 11 as an answer. But I would be careful about that because there are domain and range issues as we've seen. So what it might be a good idea is to start on the inside. Always work inside out on composition. And for arctangent 11, we know the answer to that's going to be an angle. Let's just sketch it. Let's sketch it. It has to be for arctangent in quadrants 1 or 4, as that's where we're allowed to look. And it appears to be positive, so I'm going to think quadrant 1. So sketch a triangle in which opposite divided by adjacent is 11. So something like that. Now in this case, I don't think we need the hypotenuse. We can find it, but I don't think we need it, because now we're going to take the tangent of this angle, as this angle represents this expression. And the tangent is opposite divided by adjacent. It is 11. All right, what about B, cosine inverse of cosine 5 pi over 4? It's set up a little bit differently. It doesn't have the angle on the inside. It's got that on the outside. So we could just kind of evaluate. So think in terms of unit circle. What's the cosine of 5 pi over 4? We're talking about quadrant 3, where the x-coordinate is negative root 2 over 2. So now what is the inverse cosine of negative root 2 over 2? Well, it can't be 5 pi over 4, because our output, our range for the inverse cosine function, goes from 0 to pi. Okay? So where else from 0 to pi is the x-coordinate negative root 2 over 2? And I think we're talking about same reference angle, but instead of being quadrant 3, flip it up to quadrant 2. We're talking about 3 pi over 4. So that's one where it doesn't exactly cancel out due to our domain and range issues. What about part C? Sine of arcsine of pi over 2. Are they going to cancel each other out? Do we get pi over 2? Let's check it out. So we would start here. We could do a little sketch. Arcsine pi over 2. So we could sketch it. Quadrants 1 or 4, and that's definitely positive, so we'd be sketching in quadrant 1, where opposite is pi and hypotenuse is 2. Wait, that can't happen. The hypotenuse has to be the longest side, and 2 is not longer than pi, so this can't happen. We can't have that situation. So that's undefined, since pi over 2 is not in the domain of the arcsine function. Example number 6. Again, composition, but now this time they don't necessarily match. So we're definitely going to want to go sketch on this. Work on the inside. Again, arctangent would mean that's an angle. Let's sketch it such that opposite divided by adjacent is negative 2. Since we're talking about negative here, we're going to sketch that in quadrant 4. Remember, for arctangent, the range is in quadrants 1 and 4. We're going to go quadrant 4. So not looking there, looking here. We're going to sketch at quadrant 4, opposite negative 2, adjacent 1. Now because we're dealing with sine in the end, we are going to need to do the Pythagorean theorem. So you're going to need to find the missing side. So c squared equals a squared plus b squared. So we're talking about c squared is equal to 5. It's the square root of 5. So now what is the sine of this angle that represents this expression. Sine is opposite, divided by hypotenuse. So it's going to be negative 2 over root 5. All right, part B, cotangent of arc cosine. We're going to sketch the arc cosine, that being an angle. So we're only allowed to look in quadrants 1 and 2. It's positive, so we're going to go quadrant 1. Adjacent, hypotenuse, 5, 7. Pythagorean theorem, find the missing side. It's the square root of 24. We can simplify that. 2 root 6. Now what is cotangent? Adjacent divided by opposite. 5 over 2 root 6. Okay, an equivalent expression would be 5 root 6 over 12 if you wanted to rationalize the denominator. Right, last thing we're going to look at is a true pre-calculus type problem leading up to calculus where we have a variable in there. Okay? So again, same idea. Start here. Start on the inside, work outside on the composition, and this is an angle. So we're going to sketch it. Our tangent has to be sketched in quadrants 1 or 4. We're not really sure if x is positive or negative, so we really don't know if it's going to be quadrant 1 or 4. So I would just assume then quadrant 1. So we're going to put our sketch in quadrant 1. Okay. If we're talking about arc tangent, we're talking about tangent being opposite and adjacent. So that's how we're going to label x, root 7. Now for the Pythagorean theorem, pause here as you work through the Pythagorean theorem to find the hypotenuse. So remember, c squared is equal to a squared plus b squared. So we're talking about x squared plus 7 is c squared, which is why c would have to be the square root of that. So now cosecant is going to be hypotenuse divided by opposite. There's our final answer. That's it for today. I'll see you next time.